All right, good afternoon, and thank you very much for having me up here to talk about the work that we've been doing in my group. And thank you to JCATI for the multiple years of funding. It's given us a bunch of different partnerships and some interesting outcomes. What I'm going to do, Beth had asked me to talk about sort of my experience overall in JCATI and what works well and how did the partnerships formed and things like that. So I thought, because I knew it was going to be toward the end of the day, that I would start with the takeaway points. To give you that part, and then you could totally check out, except that the movies are later. So I've learned a few things in teaching. All right, so some key things about the kinds of projects that JCATI is funding and the kinds of things that I've worked on. And the process has changed a little bit over the years, but definitely technology is changing very quickly. The kinds of things that JCATI is funding is going to engineers. And Beth, and I'm not throwing you under the bus or anything. I wanted to make sure, I know, it was good lunch. Make sure and hit some key points up here that Beth wanted me to emphasize. So one of them is that the kinds of projects that JCATI is funding, it's to help with keeping technology current in the state of Washington. And that's all parts of technology, and the kinds of projects that would benefit aerospace industry cover just a wide range of things. So a number of them were discussed today, and some of it on structures, things like we work on in other areas, aircraft handling. I mean, those are some of the, I think, more familiar applications that people think about for aerospace engineering, but it's everything like including product delivery, the people that are involved, so how would you organize the people in an organization? And it's really important, I think, for all companies to be thinking about being involved in the R&D process, and I think that there are a lot of things that can benefit from partnerships with industry and academia. But I think that I also want to sort of emphasize a few things about engineering. There are different approaches to engineering. You can think of it as being as we view it in academia as being analysis-based. So how do we use analytical tools to solve engineering? But there's also more of the experiential-based, and I'd like to emphasize the Parrot as being the experiential-based type of engineer. We work on focusing our tools that we develop, and we can do that better when we partner with industry from the academia side to help us decide what tools we should focus on developing. So we tend to, many of us focus on longer timelines, do basic research. JCATI is aiming more for sort of that mid-level, like Beth had mentioned, where we want to get things transitioned out into industry. Industry does tend to have shorter timescales. Often some of the challenges come up, their timelines are not the same as academia. We need to educate our students on the academic calendar. The University of Washington in particular has a union for our research assistants, and so we have to follow certain guidelines with how they're appointed, and that can be challenging if you haven't laid the groundwork for that first with the partners. But I think working with academia does give access to some new techniques for industry, and we're working on coming up with good ways of how we can make that transition for them. And then I think the obvious workforce training. So my area in particular, I'm a controls engineer, and so I wanted to give a little bit of just a few definitions here for guidance, navigation, and control for people who might not be familiar. So the guidance part of it is, what do you want the system to do? It might be what path do you want it to follow? It could be what task do you want it to accomplish? It depends a little bit. This picture here is with one of the companies that I've worked with on a morphing drone. And so we need it to reconfigure and to follow a path while it's doing that. The navigation part is the sensing side of things. So given the sensors on the system, how do you use those sensors, and can you use those sensors to get the information that you need in order to tell the controller, which is the last part, maybe, what to do? Oh, it had interesting animation in there. Speaking of AI, so the control part is how do we wrap feedback around that loop and get the results that we want out of the system with the sensing that we have. So the particular projects that I have worked on, so there have been 5 total over the past 5 years. This is my 5th year of funding. So the first 3 were all with Aerojet Rocketdyne, and so they are a larger aerospace company. And the particular things we did with them, I just sort of put them all together, but they were all kind of on the same theme, which was solar electric propulsion for spacecraft. The goals here, at the time that JCATI started, there was not quite such a strong, really written out, focus on the TRL, is it, what numbers now? 5? 4 to 7. Oh, I nailed it right in the middle. Good for me. So these projects were a bit more helping provide Aerojet Rocketdyne with some tools that were not already in their toolbox. And so this was some of the controls techniques for doing constrained motion planning for the system. So the satellites, they have to keep their solar panels pointed at the sun so they have enough energy, or at least keep them pointed long enough to have energy. But then you also need to have them minimizing the amount of fuel that they use. And so we were looking at how do you do that either on orbit or during a landing or something like that. And so those were different applications looking at those kinds of tools for them for the first 3 years. And then JCATI, and I think it was a perfectly good plan, decided that they really wanted to kind of diversify a bit, really focus a bit more on the technology transition, a little bit more at the application level. So the next project I worked on, and I would also say there's been an emphasis on not repeating the funding, which is perfectly fine. So a company had approached me that was doing drone manufacturing for a morphing drone, and they needed some help with the controls for the system. And so we looked at the system. So there's a picture of it here, and I'll show the movie in just a second. So they have a system where you can change the lengths of the arms, so basically where the masses are, where the rotors are on the ends of the arms, each independently, and the angles of the arms. There are a lot of reasons why morphing vehicles have not worked over the years. But the focus here was keeping it as simple as possible. We've done things to sort of constrain some of the symmetry in it so that it looks like it's doing symmetric things. The plot at the bottom here, I don't know how legible it is from the screen there, but we looked at, for this particular vehicle, how quickly could it do pitch rate changes? So basically, how quickly can it maneuver compared to a system of the same weight that doesn't have the morphing? And the analysis, assuming that the motors in the system can operate at the speeds that we dictate with the controller, it should be able to go at least twice as fast in terms of its maneuvering as a system that doesn't reconfigure. And so we're working on transitioning this to additional funding. The company does now have some venture funding, and this is an example of what you could do with that if you say lost a rotor. And so if the system can reconfigure itself, and I'll show this slower here next. So this is a slower version of that. That was real time. This is how it would reconfigure. We didn't plot the broken rotor on there, but so it could reconfigure itself and hover again within 2 seconds. So as long as you're 2 seconds above the ground or whatever you're trying to not hit, then you're in good shape. So that was last year's project, and then this year I've been working on an application using a drone with a company, another startup company called Physical, and again, they had approached me on needing some help with doing the technology side of things, and this has been, there was a poster here, my students are total rock stars for getting this demo to work this week. Let me see if it'll play. There we go, okay. And I'm gonna talk, you can just watch it. This is on YouTube too. So this is an Intel Aero drone, so we were interested in using off-the-shelf hardware as well as open source avionics. This is using PX4 and Pixhawk. So the idea here is that the vehicle is supposed to be helping with indoor inventory warehousing, so it needs to fly to particular positions and then get images of the boxes and scan the barcodes. So that whole system is what we've been working on with the company. So my postdoc, who couldn't be here today, has been developing the system to do the barcode recognition, and if you can't get a barcode, you have to identify you were not able to get the barcode by doing some things with the image processing. But he can get all the barcodes in an image as long as the resolution, I think he needs about at least 2 pixels per line in the barcodes, but all of them in the image he can get between 2 to 3 seconds. It doesn't matter what orientation they are or where they are in the space, but he can get all of them. And so this is showing a little bit of that recognition. And some other challenges with this one are if you're operating one of these vehicles indoors, you don't have GPS, and you don't have a compass because there's too much magnetic noise in the rooms. And most of those off-the-shelf technologies break if you disconnect the GPS to just say, well, I'm just not going to use it. Yeah, off-the-shelf. So anyway, we made it work. So, and you might have noticed there were a lot of liquor boxes. That's not because we're working with graduate students. It's actually because that's one of the easiest entry markets for the technology, is because the boxes are all very regularly shaped and the barcodes and the images are very clear. So we're getting into the warehouses soon. thank you to JCATI and to the partners. So I think it's been a great experience for us on all the projects.